In this video, I'm going to go over question 10 from the November 2016 paper 1 for IB Math SL. It is a complicated calculus question, also with some factorials in it, so some complex algebra. So we're given f of x equals cosine x, find the first 4 derivatives, and then the 19th derivative. So only if it's a cyclical, like repeating pattern of derivatives would we ever be asked to find the 19th derivative. Otherwise, you'd have to take the derivative of the derivative of the derivative, and it would take far too long. So the first 4 derivatives of f of x, f prime of x would be negative sine x, because the derivative of cosine is negative sine. You could always look that up in the book. The second derivative would be the derivative of the result we just found, which would be negative cosine x, because the negative stays, and the derivative of sine is cosine. Once we get to the third derivative, we don't usually write triple prime. That's where we would put a 3, which is why in the next question, when you see a 19 in there, it means 19th derivative. So the third derivative would be the derivative of negative cosine, which would be negative sine. So the negative stays, and then the derivative of cosine is negative sine. So this becomes just plain sine x. And then the fourth derivative would be the derivative of sine, which is cosine. And then the pattern would start again. So if I was to then proceed to go on to the fifth derivative, for example, it would be a negative sine. And then the pattern would repeat. So the sixth derivative, seventh, and then eighth, we'd have the 4 same repeating. And then the 9th, 10th, 11th, 12th, we would have the same 4 repeating. And then the 13th, 14th, 15th, 16th, we'd have the same 4 repeating. And then the 17th, 18th, 19th is the one that they're asking us for. So we have to recognize that that would be the third one in the pattern, which is just sine x. So the 19th derivative of f is sine x. And that's our work shown for that question. And then we're told about a new function, g of x, which is x to the k power. Find the first 3 derivatives of g of x, and this is all going to be in terms of k. So g prime of x would mean to bring down the k in front and then decrease the power by 1. The derivative of that, we would have to bring down the k minus 1 power, and there's already a k there. So you can think about it as k, then k minus 1, and then decrease the power by 1. Since it's currently k minus 1, it would become k minus 2, because that's 1 less. And then the third derivative, we don't use triple prime. We're going to write g with a little 3. And we'll bring down the k minus 2. And then this becomes x to the k minus 3. Just to prime you with what's coming, when you have a number multiplied by 1 less than the number, then 2 less than the number, that's a factorial. So factorial, if you're thinking about, like, let's say, what would 5 factorial mean? It would mean 5 times 4 times 3 times 2 times 1. If you're thinking about what k factorial means, it would mean k times k minus 1 times k minus 2, dot, dot, dot. So that's going to matter later in this question. All right, next, 2. Given that the 19th derivative of g, this function g, is equal to this expression, let's see if we can find what this p-value has to be. So here's how I thought about this question. If I know I'm looking at the 19th derivative, all right, and there's this coefficient in front, and then there's an x to the k minus 19th power. I want to look at the prior example right here, where we had the prior part of this question, where we had the third derivative of g. And if this was k minus 3, you'll notice the last part of the coefficient was a k minus 2, right? All of this together, this what I'm putting in a green box here, this is the coefficient in that derivative. And the last subtraction, k minus 2 there, is 1 less than the given subtraction right in your exponent. So that means in front of this, x to the k minus 19th, it must be k times k minus 1 times k minus 2 times k minus 3 all the way up to k minus 18. And in the question, this is what they're using as the coefficient. So I can sort of set up this equation where the thing that they're giving as the coefficient, k factorial over k minus p factorial, so that expression that has p in it, must equal k times k minus 1 times k minus 2 times k minus 3, dot, 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 all the way up to k minus 18. Because I know that's what has to come in front in the 19th derivative. So I've set up this little equation where I have 2 things I know must be equal. One of them has p in it. That's what I'm going to attempt to solve. And now I'm just going to try to get that p by itself. So I'm going to, because that's what I'm trying to solve for. So I'm going to move the k minus p factorial to the other side of the equation. So I'll put it first, k minus p factorial. And then there's k minus 1, k minus 2, dot, 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 all the way up to k minus 18. Then I'm going to divide by all of those terms that I'm underlining in blue, all here at the same time. I'm going to divide those and put them to the other side of the equation. So I see k factorial over k times k minus 1, dot, 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 all the way up to k minus 18, and that equals k minus p factorial. And at this point, I can stop and think. On the left side of this equation, k factorial is k times k minus 1 times k minus 2 times k minus 3, all that stuff. And it's divided by k times k minus 1 times k minus 2, specifically ending at k minus 18. And that equals k minus p factorial. So here's where I'm thinking p must be 19. So I jumped to this conclusion. I can see why. I'm going to show you why, in case that's not obviously clear. Because what we have on the left side here is the numerator, like I was just saying, but I didn't write, k times k minus 1, k minus 2, dot, dot, dot. This could go on forever. Over k times k minus 1, k minus 2, etc. And this specifically ends at k minus 18. All of these would cancel out, all the way up to the k minus 18. But the one on the top keeps going forever. It didn't end. It ended with an ellipsis, which means it's going to pick up at k minus 19, k minus 20, because everything before that has canceled out with what's in the denominator. So to have the expression k minus p factorial over here, k minus something factorial equals k minus 19, k minus 20, dot, dot, dot. So that p must be 19. So this was the evidence that I used to show why p must be 19. It's a complicated procedure, obviously, and there might be more elegant ways to show it, but I think that makes sense to those of us that haven't studied factorials very much. So now we found p. All right, now we have a new function, h of x, that we're told is the product multiplied of the 19th derivative of f multiplied by the 19th derivative of g, and we're told to use 21 for k, so we have a specific thing to fill in for k now. And we're asked to find h prime of x. So what we need to recognize here is that this is going to require product rule, because the h function is a product, therefore the derivative of h will involve product rule. So that's worth a point. Product rule says the first times the derivative of the second. So the derivative of the 19th derivative, this is kind of complicated. The derivative of the 19th derivative of g would be the 20th derivative of g, plus the second function times the derivative of the first. So same thing applies. We'd be looking at the 20th derivative of f. And then I should fill in what I know about these functions. So I know the 19th derivative of x. I knew it from earlier in the question. Was sine x. And I know, or can figure out, that the 20th derivative of g, it's going to be, maybe I should write down the actual g 19th derivative of g. So we never really wrote down the 19th derivative of g with 21 filled in as k, so that's what we should write here. We knew, let me go back to where the 19th derivative was. They told us the 19th derivative of g was k factorial over k minus p factorial, and then it was x times k minus 19. And then we're told, we figured out p is 19, and we're told that k is 21. So the 19th is actually 21 factorial over 21 minus 19 factorial, which is just 2. And then x to the k minus 19. Okay, so all that said, oh, I forgot k is 21, so I can change this to k minus 19, which is 2. Okay, all that said, now I can go back to the step of the question I'm at, which is right here, the 20th derivative of g, which is the derivative of the 19th derivative. So I'm trying to find the derivative of this. I'll bring the 2 down. It's going to cancel out with the 2 that's already there and leave me with 21 factorial, and then decrease the power by 1. So that's just x. Okay, plus, now we're back on track. G 19th derivative, which is the 21 factorial over 2 times x squared from the red box, multiplied by the derivative of the 19th derivative, so the derivative of sine x, which is cosine x. All right, so now we have all of the pieces of our product rule. That's sufficient for C1 for H prime. And then for C2, hence show that H prime of pi equals this. So we're just going to be plugging in pi for X for part 2. So if you're thinking, wow, this question is insane, you're right. Question 10 often feels that way. You can usually squeeze out a few points from each part of the question. So I'm plugging in a pi everywhere I see X. And then I'm going to see what I can simplify. It looks so complicated, but if you realize that the sine of pi is 0, then this whole term is going to be 0. The cosine of pi is -1. I'm just getting that from my unit circle. Pi is over here, and I know the coordinates are -1, 0, so I can figure out the sine and cosine really quickly. So if the cosine of pi is -1, then I can rewrite this as minus 21 factorial over 2 pi squared. And if you look at what this question asked us to do, it was a show that question. So we just have to show our final result matching their final result. And finally, that is all.